We used a powerful AI model to bring two opposing minds to life.
Hi, I believe the Earth is flat.
And I believe the Earth is a globe. These two thinkers will go head-to-head in a structured debate. To keep things fair, we brought in 5 different AI systems to act as unbiased judges, each rating the strength of every argument point. Don't skip ahead. See if your reasoning aligns with the machines. The debate starts now. If the Earth is round, why does the horizon always look flat to the naked eye?
Whenever I go to the beach, climb a mountain, or fly in a plane, the horizon looks completely flat. If Earth were truly a ball, I'd expect to see a noticeable curve, but I don't. The water looks level, the buildings don't lean, and I'm not buying the argument that it's too big to notice. The curvature should be visible at some point. All I see is flat, flat, flat.
The reason you don't see the curve easily is because the Earth is enormous. The curvature drops about 8 inches per mile, which is almost imperceptible to the human eye at ground level. But it's detectable. Ships disappear hull first over the ocean, and from high altitudes, like 35,000 feet in a plane or via weather balloons, the curvature is clearly visible. Plus, if Earth were flat, you'd be able to see impossibly far distances, which we can't.
You say weather balloons and high altitudes show curvature, but most of those videos use fisheye lenses. They distort straight lines. As for ships disappearing, that's just perspective and atmospheric conditions. You can often zoom in and bring those ships right back into view with a powerful camera. If it were really due to curvature, that wouldn't be possible.
Zooming can bring objects closer, but it can't raise what's already blocked. Hulls disappearing before the mast is a curvature effect, plain and simple. And there are plenty of amateur weather balloon videos with non-fisheye lenses that still show the curve. If Earth were flat, we'd have countless contradictory observations, but all evidence, from laser measurements to skyline drop-offs, points to consistent curvature. If the Earth spins at 1,000 miles per hour, why don't we feel it? You don't feel the Earth spinning for the same reason you don't feel motion in a smooth airplane. You're moving at a constant speed. We're rotating with the Earth and the atmosphere, so there's no sudden change to notice. But we can detect the spin indirectly. The Coriolis effect causes weather patterns to rotate differently in the north and south hemispheres. Foucault's pendulum swings in different directions based on location. That's Earth's rotation in action.
I get what you're saying, but it still doesn't make sense to me. If the ground were spinning that fast, wouldn't we feel something? And if we jump, shouldn't the Earth rotate underneath us a little? Yet we land in the exact same place. Also, planes flying west should take less time than flying east, but flight times are too consistent for that. If Earth's spinning, the effects should be obvious. They're not.
You're already moving with the Earth when you jump, same as being inside a moving train. You don't fly to the back of the cabin when you hop. And flights do vary with wind, especially jet streams that exist because of Earth's spin. Plus, long-range weaponry and navigation systems factor in Earth's rotation. We might not feel the spin, but we absolutely measure it, consistently.
You're putting a lot of faith in effects you can't directly feel or see. If all this were true, why isn't it part of daily experience? I've seen pilots say they don't adjust for curvature or spin. If it's real, it should be obvious. And it's not. It feels like the ground beneath us is solid and still, and I trust that instinct more than models and pendulums.
How do you explain the sun setting and rising every day?
The sun isn't setting behind a curve. It's just moving away from us, like a spotlight. As it gets farther, it appears lower and eventually vanishes due to perspective and atmospheric fade. It's the same way a street lamp looks lower the farther down the street you go. On a flat Earth, the sun circles above us, lighting different parts of the world. That explains time zones without needing a spinning globe.
If the sun were just moving away on a flat plane, it would get smaller as it disappeared. But it doesn't. It stays the same size and literally dips below the horizon. On a globe, this makes perfect sense. And if you climb a tall building, you can watch the sunset again, a phenomenon impossible on a flat plane. This is all due to the Earth's curvature, and it's something you can test yourself.
But the sun does shrink in some time-lapse videos, and that double sunset thing is just an optical illusion. You're interpreting it as curvature, but it could just be light bending or refraction. The fact that we need to go higher just to see the sun again doesn't prove a curve. It just means the sun's position changes based on distance and angle. That doesn't require a round Earth.
Atmospheric effects exist, yes, but they don't explain the sharp line of the horizon or the way the sun's light fades below it. You can't hide half the sun due to distance. The consistent angle and speed of sunsets worldwide match a rotating sphere. And the fact that night falls completely rather than fading endlessly in distance further proves the sun is dropping behind a curve. Why does water always find its level and never curve? Water finds its level is true, but level doesn't mean flat in the global sense. It means perpendicular to the force of gravity. On a spherical Earth, that means water curves along with the planet, forming a level surface relative to gravity. Over large distances, like oceans, that surface is actually slightly curved, not perfectly flat. Satellite imagery and long-range measurements confirm this.
But we've never seen curved water. A glass of water is flat, a lake is flat, and the ocean looks flat. You're telling me the ocean curves around the Earth, but there's no visible evidence. And if gravity is holding billions of tons of water to a ball, how do birds fly or clouds float? The whole idea of curved water feels like a mathematical abstraction, not a real-world observation.
At small scales, water appears flat because the curve is too small to notice. But over long distances, engineers do account for curvature. Look up bridge design, canal construction, or long-distance surveys. Also, satellites orbit Earth by falling around its curve, something only possible if Earth and its gravity is spherical. So, yes, water curves, but in ways that match scale, not intuition.
You're using math and models to explain something we don't actually see. Real-world water looks flat, acts flat, and builds on flat foundations. I'm not saying math is useless, but when you need equations to see the curve, maybe the curve isn't really there. I stick with what we observe, and what we observe is flat water.
Why can't we see the curve from an airplane?
If I'm flying at 35,000 feet, I should clearly see Earth's curve. But every time I fly, the horizon is still flat and at eye level. That doesn't add up. NASA says you need to be much higher, but that's just moving the goalposts. If the Earth curves, why hide it? The only reason I ever see curvature is in GoPro footage, and those cameras distort everything. Without that, it's flat as a pancake.
Most commercial flights are just barely high enough to begin detecting curvature, but it's subtle. At cruising altitude, the curvature is visible especially with a wide enough view. Even without GoPros, balloon footage with standard lenses shows the curve. And the reason the horizon stays at eye level is because your line of sight adjusts as you ascend. It doesn't mean the Earth is flat, just that your visual frame adapts as you move up.
That's convenient. Always too high or too low. If Earth is curving beneath us, it should drop below us, not stay aligned with our eyes. Also, most planes don't have the field of view to prove a curve. What we see looks exactly like a flat plane. And that's with our own eyes, not edited photos or balloon videos.
You're right, it looks flat at first. But so does the ocean from shore, and we know that curves. Human vision is limited. Curvature doesn't mean a dramatic drop, it's a gradual arc. That's why scientists use instruments, not just eyesight. But the fact remains, every reliable, instrument-based measurement, from plane altimeters to satellite telemetry, confirms a curved Earth. Why are the stars always in the same place if Earth is moving through space? The stars appear fixed because they're unimaginably far away. Earth's movement, rotation, orbit, even our journey through the galaxy, barely changes our perspective relative to those stars. But astronomers do detect tiny shifts over time. Polaris hasn't always been the North Star, and star maps do evolve. These small changes are consistent with a moving planet in space.
But we're told Earth is spinning, orbiting the sun, and flying through space. Yet the stars never change? That defies logic. Polaris has stayed put for centuries. The constellations haven't budged. If we were really moving like that, the sky would look different every year. It's more likely the stars are fixed on a rotating dome, simple and observable.
Actually, Polaris is slowly shifting, just not fast enough for casual observation. Over thousands of years, our sky does change. Southern Hemisphere stars differ entirely from the North. A dome can't explain two opposite star trails in each hemisphere, but a globe with two viewpoints absolutely can.
Again, it comes down to trusting systems we can't verify ourselves. These supposed long-term changes require thousands of years to confirm. All I know is what I see, a sky that looks the same every night. That doesn't feel like we're spinning or zooming through space.
How do lunar eclipses work on a flat Earth?
Some of us believe there's a hidden object, sometimes called Rahu, that causes the lunar eclipse. It's not the Earth's shadow, especially since there have been documented cases of the sun and moon both appearing above the horizon during an eclipse. That shouldn't be possible if Earth is between them, so clearly something else is going on.
Lunar eclipses are simple to explain on a round Earth. The Earth moves between the sun and the moon, casting a circular shadow every time. That's something only a sphere can do from any angle. Those sun and moon both visible moments are due to atmospheric refraction. The sun isn't physically above the horizon. It just looks like it.
Refraction always seems to be the go-to answer when things don't add up, and Rahu might sound out there, but at least it explains the oddities. Plus, your model depends on a perfect alignment, yet these eclipses are surprisingly frequent and predictable. That feels staged.
It's called orbital mechanics. The moon's path around Earth is regular and measurable. That's why we can predict eclipses to the second. Rahu has never been observed. Meanwhile, we can see Earth's round shadow slide over the moon. And it's never once come out square, flat, or angled. Why can't we go to the edge of the Earth if it's flat? You can absolutely go to Antarctica. Thousands do each year, including scientists, tourists, and researchers. The Antarctic Treaty prevents military claims and environmental damage, but not exploration. People have skied across it, flown over it, and mapped it extensively. If there were an edge, someone would have found it and filmed it.
Except that all of those trips are tightly controlled. You don't get to wander where you want. Independent exploration is next to impossible. The fact that so many nations signed a treaty about a frozen wasteland should raise eyebrows. If Antarctica is actually the edge, or surrounds the flat Earth, of course they'd hide it.
Thousands of non-governmental researchers and tourists have visited. If they were hiding a wall or edge, someone would have leaked it by now. People walk across Antarctica. They don't fall off. That alone debunks the idea of a surrounding ice wall.
Or maybe they're not allowed to get close to it. All trips are guided, all routes are planned. If someone actually found the edge, it wouldn't make headlines. It would get shut down. Until someone independently documents a full, unrestricted trip, I'll remain skeptical.
Why do some Southern Hemisphere flight paths seem strange or inefficient?
Some southern flights, like Santiago to Sydney, have strange detours or layovers that only make sense on a flat Earth. On the globe, the route should be a short arc over the South Pacific. Instead, planes sometimes route through the US or even Europe. That suggests the distances on a globe are wrong and only match on a flat map.
Those layovers are due to airline economics, not geography. But direct flights do exist. Qantas 27 flies straight from Sydney to Santiago in under 13 hours. On a flat map, that route would be impossibly long. On a globe, it's a great circle route, the shortest possible line between 2 points on a sphere.
Even if those flights exist, they're rare and sometimes inconsistent. I've heard stories about unusual GPS data and strange time logs. It just feels like something is off with these southern routes, especially when you compare them to how northern hemisphere flights are handled.
Flight paths follow wind patterns, fuel efficiency, and traffic. If your theory were right, GPS systems, airline schedules, and fuel calculations would fail constantly. But they don't. Every airline operates based on globe coordinates, and they work because Earth is a sphere. Why haven't we seen undeniable video of the Earth rotating in space? Actually, we have. The Himawari 8 satellite provides near real-time images of Earth every 10 minutes. The DiscoVR satellite captures Earth from 1 million miles away. And the ISS livestream shows Earth turning beneath it constantly. These aren't animations, they're raw satellite data. The problem isn't the footage, it's that flat earthers don't believe it.
Because it's all curated. Why not give us one uninterrupted camera angle, zoomed out, showing the Earth spinning, with no cuts, no edits, no overlays? If the Earth is spinning, it should be obvious. Instead, everything looks rendered, filtered, or stitched together. That doesn't inspire trust.
There are uninterrupted feeds. You just choose not to accept them. And it's not just NASA. Other countries and private companies show the same thing. Plus, amateurs have launched weather balloons that capture curvature and motion. Not everything is CGI.
I've seen those balloon videos. Many show flat horizons until the camera bends them. And I'm still waiting for a camera that shows a spinning Earth without needing a data explanation afterward. Until then, I'm not convinced.